Now that we've got the basis, of probability and a better handle of sample space, desired event, and complement. Let's do some examples in statistics. All right, here we go. All right. My neighbors are playing wonderful music. In a test, a gender selection technique results consisted of 277 baby girls and 271 baby boys. Based on the result, what is the probability a girl born to a couple using the technique? This is a technique. Sorry, I missed that word. Does it appear that the technique is effective in increasing the likelihood of baby will be a girl? So now we're going to assess the probability. So let's put it in parts. First, we find the number of the sample space. Well, it's total girls plus total boys. All right, so let me make a little bit room. So the total girls is 277 and the total boys are 271. So our sample space has a total of 548. Right, so we know that number. Construct the P of girls using this technique. All right, so we want the P of girl being born All right, so that means that we want the probability of a girl over the probability of the sample space. Okay, so we're going to have the number 277 over the sample space of 548. Okay, so let's do our ratio. Seven, seven, 548. And we get this number. Okay, so I'm going to put my calculator to the side. So I get this number, 0.50547 and forever. All right. So we want to use 3 decimals, one more than, because it is mathematics. So we're going to say 505. So now we're going to assess. Well, that's slightly higher than 50%. Is the technique appear effective? Higher than the 50% already known. So now, um, so is it effective? Not, no, not statistically. because it is closely related a 50% chance. So the treatment, and it probably gives you a feeling, um, that it is possibly going to happen. All right, so let's do another example. Right. On their first date, Kelly asked Mike to guess the date of her birth, not including leap year. Complete A through C. So let's look at this. What is the probability that Mike will guess correctly? All right. So we have to know a few things. First, we have to know the sample space. So then we know that there are 365 days in a year. So we'll use that value as our sample space. Then we have to know Kelly's birthday. Well, it is specific. Don't know what it is, but it is specific. So it's 1. So now we're going to construct our probability. The probability of uh, Kelly's birthday over, uh, I'm sorry, not probability. Number of Kelly's birthday and the number of the calendar year. So Kelly has a unique birthday date out of 365. So would it be unlikely for him to guess correctly on this try? Yes. Would it be unlikely? Uh, the 1 over 365 equals, so we're going to do the calculator, 0.0027. Okay, so it's very slight. It's not even 1%, right? So let's see what else they ask us. If you were Kelly and Mike did guess correctly on the first try, would you believe his claim that he made a lucky guess? Or would you be convinced he already knew when you were born? All right. Because it's our first date, I would I would surmise Mike already knew Kelly's. Also supported by the statistic. The probability of Kelly's birthday by guessing was 0.0027, very low. So there we have both a subjective the first part I summarized already knew. Well, that's a subjective. I felt that the only way he could get it correct was if he already knew. Well, then I have the support of the statistics. Statistics said it was 0.0027 chance of him getting the right item. All right. So now we want to discuss this one, where we talk about how to do several things. Number one, we have to construct all possible uh, occurrences. Now, this will make sense as soon as I read it to you. The sample space listing the 8 sample events that are possible when a couple has 3 children is boy, 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 girl, boy, girl, boy. Notice that order is important. Boy, girl, 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 boy, 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 girl, boy, girl, 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 boy, girl, 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 girl. Okay. After identifying the sample space for the couple having 4 children, find the probability of getting 2 girls and 2 boys. All right. So we're going to construct that set. All right. So let's begin easy, like they did. Boy, 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 and boy. All right. So that's our first one. So then let's add a girl to the mix. Boy, 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 girl. Well, then we could have boy, boy, girl, boy. And that's different. Boy, girl, boy, boy. All right. So now I have had boy as the first element. So I'm going to do another boy where we have 2 girls. So we're going to have boy, boy, girl, girl. Then I'm going to have boy, girl, boy, girl. Then I'm going to have, oops, that's a boy, boy, girl, girl. So each one of those is unique. So I'm good there. So I did the 1 girl, I did the 2 girls, and now I'm doing 3 girls. And the only way, we're going to start with boy, girl, girl, girl. All right. So this part right here is with boy first. Now we're doing girls. Okay. So I can have girl, girl. Then I can have 1 boy. Girl, 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 boy. Now I'm going to move the boy around. Girl, girl, boy, girl. Girl, girl, boy, sorry. Girl. So now that's with 1 boy in a mix with 3 girls. Now I'm going to do 2 boys. Girl, girl, boy, boy. And I'm going to mix it up. Girl, boy, girl, boy, girl, boy, boy, girl. All right, now that's that one. Well, the only one left. Now I had 2 boys. I have 3 boys. Girl, boy, boy, boy. All right. So how many is a sample? All right. So we've got 4, 7, 8, 4, 7, 8. So we have a total of 16. Okay. So now that we have that, we're going to answer the next question. So let me put this closer. All right, so we can have an idea. Identify the sample space for the couple having 4 children. So we did that just above. Find the probability of getting 2 girls and 2 boys in any order. All right, so now in our sample space, we're looking for 2 girls and 2 boys. And it looks like we've got 6 of them. Is 16, and N of 2 boys and 2 girls, any order, is 6. So the probability of 2 girls and 2 boys, any order, is going to be 6 out of the 16. So now we're going to use our calculator. And I get decimal 375. So it's about 40% chance of getting what they wanted. All right, so now we're saying information about very important aspects of what we've done so far. And these are both to determine if the results are significantly high or significantly low. And this leads to that, what I started with in this lesson. And that is first to see if probability of an event is greater or lower than the confidence interval of likely. In other words, when we do statistics, we're saying, well, there's a 50% chance, well, there's a 40% chance. And that gives us that condition. We're talking about the tails. All right. So we know that if we have our number line from 0 to 1, which is statistics, we can have um, 50% and 1. Okay. Here's the 50-50 chance that we had on our drawing. And here's a certainty and unlikely. So if the data that we're evaluating is on the low, then right here is 0.05 for this position. So if it lies in here, it is significantly low. Well, over here is also 5%. This one, I have to put it as the area in this section, 5%. Then it is significantly high. So that is the litmus test. We're talking about a litmus. When we say litmus, it is something we use in science where you change, where it changes to blue or yellow. And it tells you if it is alkaline or it's not alkaline. It's a litmus test. It's a 5%. All right. So let's talk now of what the book says. Significantly high numbers of success. X successes among N trials is significantly high number of successes if the probability of X or more successes is unlikely with a probability of 5% or less. That is, X is slightly high number of successes if P of X or more is less than 5%. All right. So, because we have this part would be likely, and this is unlikely. All right. But if this number is more than 5%, then there's a challenge to the outcome of our statistics. Oh, pardon me. Significantly low number of successes. X successes among the N trials is significantly low number of successes if the probability of X or fewer successes is likely with a probability of 5% or less. Again, that is a significantly low number for it to occur. So let's use it and make sense of determining one or the either, one or the other. Sorry. Okay, so here we go. It's the probability value to determine whether the sample results could easily occur by chance, then form a conclusion. All right, so we're evaluating. We're given the data this time, and we're evaluating. A study addressed the issue of whether pregnant women can correctly predict their gender of the baby. Among the 104 pregnant women, 7, this is N of S, 57 predicted gender. Right. If the pregnant woman had no such ability, there is a statistic of 327 thousandths percent, or 33% probability that such a sample results from chance. What do you conclude? So our sample probability is as follows. P of predicting gender gender is 57 over the 104. That's our sample. We're going to do the math. Clear that. And we're going to enter the 57 divided by the 104. And I get 50-50, almost greater than 50. 548. 548. We're going to do 3 decimals because they were given to us as the probability of selecting your gender by a bigger study. And that's what we said. If no such ability, having issues writing, aren't I? The tile for the probability of a guess, generally, from some other study, I'm sure, with a larger sample, 327 thousandths. So, let's do some math. We're going to find the difference. From the sample and the no abilities. So that would mean that I'd have the decimal 54.8 minus the decimal 327, because that difference is what we're looking for to measure with that 5%. So let's use our calculator. Decimal 548 minus decimal 327. And we get 22.1. All right. Thousandths. The probability shows, so we're going to assess. Let's see what we can assess. What can we say? Probability shows that the sample result could have easily occurred by chance. Okay? And what else can we say? It appears that there is not sufficient evidence that pregnant women can correctly predict gender of their babies. So we have that comparison wheel. Well, how do we state this this assessment? How do we the inference of what the data says? Well, what we did was 548 thousandths minus the 327 gave us the 221. Now, the difference, and this is our support, not subjective, but support by our evidence. Difference is greater than the 0.05. This number than this number. Therefore, we cannot support. The ability of pregnant women knowing gender. All right. So we're in odds, and this is that last section. So I'm going to stop right here, and we'll start again with this when we return.